Alright, so let's go through the trial exam 4, which is a 2021 A-level question. So, okay, in a child's toy, right, a small boy move along a smooth track. So the ball move along a straight slope and then travel around a vertical circular hoop as shown in this figure. So the loop has a diameter 24 centimeter, and of course the slope has a length of 56 centimeter. So here 56, right, and is inclined 40 degree. Initially the ball is at rest, so meaning that the speed is 0 at the top. Okay, for part A, for the ball moving down the slope, right, calculate what is the acceleration of the ball. So this one 2 marks, right? Okay, for this question is actually testing us on our resolving of vectors. So for example, right, we know that, okay, this small ball, there's a weight component, right? So the weight component is mg, and of course when you look at the slope, don't forget to resolve. So there's a so-called a perpendicular component, there's a parallel component. So when I say perpendicular and parallel component, is with respect to the slope. Okay, so what is causing the ball to move or accelerate downwards is actually this parallel component that I highlight right here. So this light blue color component is causing the ball to accelerate downwards. Okay, so with this, right, okay, you must know that what is the parallel component with in terms of the theta and your mg. So always remember your mg is your hypotenuse, then the green color one, right, is your adjacent, and of course the blue color one will be your opposite. So this thing right here is theta, so I simply just use, right, mg sine theta. Now why is it mg sine theta? Because you think about it, right, so if I draw the right angle triangle, so this is your mg, then this one is your adjacent, so this is your theta, right? So of course the parallel component is here. So obviously you can see that this is opposite, so you just use sine theta equal to oppo divided by hypo. So opposite is just mg sine theta. So this is mg sine theta. So this mg sine theta force is causing the ball to accelerate downwards. Okay, of course I want to determine the acceleration, so I must use F equal to ma. So F equal to ma is this, F equal to ma, and of course the F, right, is the mg sine theta, because this is the force that caused the thing to accelerate downwards. So mg sine theta equal to ma, and you can actually cancel out the m, right? So it's g sine theta equal to acceleration. Then of course you sub in. So for example, right, g is 9.81, then theta is 40 degree. So if you calculate correctly, your acceleration should be roughly 6.31 meter per second square. So that is how you do the first part A. Okay, so for part B, part 2, use the answer in part I, right, to determine the speed of the ball at the bottom of the slope. So for this question, it's actually testing us on our kinematics, the so-called the equation of motion, the 3 equation of motion, right? So I want to determine what is the final speed at the bottom of slope. So of course I know the initial speed. The initial speed is, so I put u first. Okay, the initial speed is u equal to 0. I want to know my v. So you must choose one equation of motion. So if you choose one, okay, let me just write down the 3 first. The 3 equation of motion. First is s equal to ut plus half at square. Second is v square equal to u square plus 2as. Third will be your v equal to u plus at. Obviously, you can see that first and third we cannot choose first and third because I don't know what is the time. I can only choose the second one because I know my u, I know my a, right? I also know my s. So s is your 50, the length of the slope. So the length of the slope is roughly 56 centimeter. So this is 56 centimeter or 0.56 meter. So based on this, right, I can choose that, my second equation of motion will be the formula that I use in order to solve this question. So v square equal to u square plus 2as. So this is 0, then this is not 9.81, because it's the so-called the acceleration along or parallel to the slope, right? So this is 6.31, and then the s is 0.56. So of course you calculate 6.31 0.56, so this will give you about 69 is it, sorry, 2 times 6.31 times 0.56, Okay, sorry, my calculation mistake. So it's about 7.0672. Then just square root. So V equal to square root of 7.0672. So this will actually give you a final speed of 2.658420584. Round off to 3SF, 2.66 meter per second. So that's the final speed. Okay, so now we move on to the circular motion part. So part B, right, the speed of the ball is at the top, right, is about 1.5 meter per second as shown in the diagram. So we have a ball that has a mass of 72 grams. So we are asked to determine the magnitude of the centripetal force acting on the ball. So centripetal force, right, the formula that comes out will be F equal to mv square over r. Or you can use m/r omega square, but we are given all these speed and the mass, right? I simply just use mv square over r. Okay, so first will be the magnitude 2 marks. So this will be, mass will be about 0.072 kg. Then the speed 1.5 square. Then what about the radius? The radius is the radius of the so-called loop. So in the first part, right, let me just go back. The first part, we are given that the diameter of the loop is about 24, meaning that the radius, right, is about 12 centimeter or 0.12 meter. Just sub in, then you will get the answer already. So this will be 0.12 meter. So if I do my calculation, I will get, okay, so my centripetal force is 1.35 Newton. So that is quite straightforward also. So 2 marks also give away one. So 1.35. Okay, so now I move on to the last part. This one more challenging. So part 2, right, determine the magnitude and the direction of the force due to the track acting on the ball. So this is the keyword, due to the force due to the track acting on the ball, meaning that this purple color highlighted statement, right, is the normal contact force. Okay, so let's go back to the diagram. Okay, so imagine that now my ball is exactly at the top already. So when it's at the top, there are two forces that provide the centripetal force. Because you want to move in a circular motion, right, you must have a centripetal force. So there are two forces. First will be the weight of the ball. So the weight of the ball will actually provide the centripetal force. Second will be your normal contact force. And we are asked to find this normal contact force. Okay, so with this, right, we must understand that the centripetal force is normal contact force plus the weight, which will give you the centripetal force. So since I know what's my centripetal force as calculated previously, I also know my weight already, right? So I can determine my normal contact force. So let's do the calculation together. Okay, so normal contact force plus weight. So this will give you centripetal force. So centripetal force is 1.35. The weight of the ball is, let me just go back. Okay, 72 grams, which is the mass. So 0.072 kg multiplied by 9.81. That will be the weight. So let's do the calculation. So 1.35 minus away the weight. Okay, so my normal contact force is about 0.64368, or you can round off to 0.644 Newton. So that is the magnitude, 0.644. Of course, the direction, right, you must say downward. Acting, maybe you can just write down acting towards the center of the circle. Towards center of circle. Done. So that is how you do this 2021 A-level question.